In data science, sometimes the biggest threat to your model isn't some complex algorithm, it's just a single hidden number. Welcome to day 13. Today, we're talking about outliers, those weird data points that can quietly sabotage your entire analysis.
So, can one number really ruin a whole dataset? It sounds kind of dramatic, doesn't it? But a single strange value can throw everything off. So how much damage are we really talking about? By the end of this, you'll know exactly how to spot these troublemakers and, more importantly, what to do about them.
Okay, let's make this real. Take a look at this list of numbers. You've got 15, 18, 7, 13. You see the pattern, right? They're all kind of hanging out in the same neighborhood. And then there's 101. It doesn't just stand out. It feels like it showed up to the wrong party. That is your classic odd one out. That's an outlier.
Okay, so what's the big deal? Why is this one number such a problem? Well, it's not just about looking weird. It has a real, measurable impact on how we understand our data.
Formally, an outlier is just a data point that's way different from everything else. Now, this could be a simple mistake. Maybe someone typed a number wrong. Or it could be something genuinely rare and important. And that's the tricky part, right? We have to figure out if we're looking at junk or a hidden gem.
And this is where you really see the damage. With that 101 in the mix, the mean, or the average, is over 24. But the moment we take it out, the mean drops all the way down to about 13. That's a huge change. Now, look at the median. It barely budges, just from 15 to 14. This shows you the core problem perfectly. The mean gets totally dragged around by outliers, but the median, it's solid, it's robust.
Sure, spotting 101 in a tiny list is easy, but what if you have a million data points? You can't just scroll through and eyeball it. We need a system. So let's look at a couple of common ways to hunt these things down.
Probably the easiest way to start is just by looking at the data, and a box plot is perfect for this. The box in the middle shows where half your data lives. The lines coming out, the whiskers, show you the normal expected range. Anything that falls outside of those whiskers, bam, that's a potential outlier. Flag for you right there. It's a great first check.
Okay, visuals are great, but sometimes we need a hard number. That's where the z-score comes in. The idea here is simple. We want to measure how far away a data point is from the average, but in a standardized way. The z-score tells you exactly that. How many standard deviations is this point from the mean?
And how do we use it? Well, it's a pretty simple process. First, you calculate the z-score for every single data point using the formula here. Then, you just apply a common rule of thumb. If a z-score is bigger than 3 or less than -3, you've likely got an outlier. It's a really standard, reliable way to put a number on just how weird a value is.
Now, another really powerful tool is the interquartile range, or IQR. The key difference? The z-score uses the mean, which we already know is sensitive to outliers. The IQR method, on the other hand, is based on the median. It focuses on that stable, middle 50% of the data, which makes it much less bothered by outliers.
So here's how it works. First, you sort your data and find the quartiles, Q1 and Q3, which mark the boundaries of that middle 50%. Next, you calculate the IQR itself, which is just Q3 minus Q1. Then, you use that IQR value to create a normal range with an upper and lower fence. And you guessed it, anything that falls outside those fences is considered an outlier. It's a super robust method.
All right, so we've found our outliers. Mission accomplished? Not quite. Now we have to decide what to do about them. You can't just leave them there. So let's talk about 3 common ways to handle them.
You've basically got 3 main choices: trimming, capping, and imputation. Think of trimming as the most drastic option. Capping and imputation are a bit more gentle. They're about changing the value, not deleting the whole data point. The right choice always depends on your data and why you think the outlier exists.
First up is trimming. This one's easy to understand. You just delete the outlier. Gone. It's like baking cookies and just throwing out the one that got burnt. Super simple, right? But you have to be careful because you're literally throwing away data. So use this one with caution.
A less drastic move is capping. Instead of deleting the value, you just cap it. You set a ceiling, a maximum allowed value, and anything above that gets pulled down to that ceiling. So for our 101, we might say the highest reasonable value is the 90th percentile, which is 20.7, and just change the value. You keep the data point, but you tame its extreme influence.
And our third option is imputation. This is where we replace the outlier with a good guess for what it should have been. A really common choice is to just replace it with the median. Why the median? Well, like we saw before, it's not affected by outliers, so it's a safe, stable value to plug in. This way, you keep your data set the same size, but neutralize that problematic value.
Okay, that's all great in theory, but why does any of this actually matter when we're building machine learning models?
Here's the bottom line. Outliers can seriously mess up your model during training. They pull its attention in the wrong direction, which leads to less accurate predictions and a model you can't really trust.
Think about a model to predict house prices. If most of your data is for normal suburban homes, but you have one data point for a $10 million mansion, that single mansion can completely warp your model's understanding of price. By dealing with that outlier, you're making sure your model learns from the typical houses, not the crazy one-off anomalies.
And that's really the whole point. Dealing with outliers isn't about cleaning up messy data for the sake of it. It's about building models that are stronger, more accurate, and that you can actually trust.
So remember, there isn't one perfect answer here. The real skill is finding that happy medium. You want your analysis to be just right, so it's not thrown off by weird values, but you're also not ignoring something that might be important.
So I'll leave you with this thought. Is an outlier always a mistake? Or could it be the most important discovery in your entire dataset? Sometimes it's a typo, but other times it's the sign of fraud, a scientific breakthrough, the one thing you were actually looking for. So the key isn't just to eliminate them, it's to understand them.